Now, only one Pablo has a lot of person that will lean on him in life. Only one Pablo now. More than 1,000 persons in this generation are waiting for you to make it. Now, if of all these people will cut off. If I'm not here, many of us will not be here now. Serious. If I'm not here, some of us, whether I like it or not, somebody will make somebody to be somebody. That is just the truth. You cannot, we are in a world that only you cannot get to it by yourself. So you need a ladder to climb. Now, because of that, I have to act safe. You act safe. Then the action on safety is what we are talking about. We said there are so many safety gadgets. Do you use those safety gadgets at sites? We said there are so many safety things. Do you use those safety things at sites? We said safety first. Now, once you act safe, then you will be safe. Your safety is in your hands. Your safety is not in my hands. Take note of that. That you are safe at site, it depends on you. You cannot get to site, then you just see a ladder. You climb on the ladder, and the ladder is not okay. You know that this ladder is not okay. These two guys, they are not here. The ladder they want to use, they know that it's not okay, and they climb on that ladder. Then the next thing, at the extreme end of your climbing, you hear bar. Then you will now use your head to hit the wall. Is it me that suffered the pain? It's not me that will be terminated. So now, it's you. My safety is in my hand. Because my safety is in my hand, if I'm crossing this road now, I will look at this way, I'll cross. Now, I cannot get to the road. I just run and I want to cross. Because my safety is not in Pascal's hand. My safety is not in Precious' hand. My safety is in my hand. That is why, as long as I can think normal, I have to look here. This is coming. I calculate. Will this bike get to this place before me? Then I cross. The same thing is applicable at site. I want to climb. I am going to the roof. First thing that I need is what? Harness belt. Safety gadgets. We call it personal protective equipment. One, harness belt. Ensure it's not just to tie belt too. If you tie belt and you go up, it's as good as you did not tie the belt on your waist. What you do is two ends of the, just make sure that there is a place you clip your belt. And if I have a building like this, then I put rope here. I'm walking here. And I bet myself with this rope. But this my rope did not get to the other end. And I'm walking here. What will happen? If the person wants to fall to this side, you will fall with the rope. You understand? So that is why your rope should also hook here. I don't know if you understand. If my rope is hooked to this place and it's hooked to this place, and if I'm walking here, any attempt for me to fall to this side, this one will hold me. Any attempt for me to fall to this side, this one will hold me. So that is why your rope must be two-ended close. Close both sides. Don't close one side and feel that you are safe. Then, if I am at this point also, I will need the two ends, because see, Any small mistake can make somebody to fall. I don't know if you understand. Small, just a little mistake. You match something before you know, your 2 hands are off the system. Then the next thing. Now, when somebody fall, 2 things are at stake. It's either the person will lose the life or the person will disable. Like one part of the body. Imagine somebody falling from a very high elevated ground, and you are telling me it's either the hand will break, the leg will break, or if not, the heart will even cut. So please, safety conscious. Then another thing again that I need is what? Number 2. What do you need? You need helmet. Or they call it what? Huh? Spell it for yourself. So now, there are sometimes somebody will be walking at the roof, and trust me, while walking, the next thing that will happen is maybe a spanner fall off from the person's hand, and the thing is falling from up, and you are standing because you are feeding them with panel. Now the next thing you hear on your head, it will open it. Then what will happen to the person? Huh? What will happen to the person? Huh? What will happen? Position them, let them see them. What will happen to the person? It can lead to death. It can make the person to permanently disfigure. And that your career, end of the road. Think safety. So you need helmet. You need helmet. Then also 3, safety shoe. I use some occasion. How many? And why is he calling? You call him now. What did he say? No people consist. Talk to this man. Come. Tell him where you are. Hello? So, now, number 4. What else do you need? Safety. Huh? You need hand glove. And the rest of others. On our safety course, I'll teach us so that I'll not waste too much time. So now after I've think safety, then tools needed. I talk about the tools needed. For you to succeed in any work, there are tools that you need to work with. And it's necessary that all the tools needed, you have them handy. Now let's talk about what are the tools that we need to do this work. Number 1. Huh? Sit down. Okay, fine, deal. Tools needed for this work. 1.
Like you need tools to actually do work or the things that work.
Okay, tools needed for this work. 1.
Ladders.
Two. 15 naira if you don't have answer. Oh yeah, good. Huh?
Driver.
Oh yeah, 15 naira.
Tesla.
Tesla, which type of Tesla?
For goods.
For boutique.
That's
But you fail it, oh yeah, give me another one. Give me a desk. Okay, I'll give it to him.
We need our rope.
yes.
Honestly. Give this guy 15.
What's your name?
No, pardon you. Because you are sick, you are you shame injection. Oh yeah. Fast. Huh? But the way I choose, I need to. Oh yeah, book. Next. Spanner. Those are right. Number 8. Number 8.
Hammer.
It's plenty now. Number 9. Listen to. Yes, now.
D2. Now material.
No.
It's item.
Let's be there for the work.
No, it's not choose, it's item.
It's item.
Yes.
Give me.
It's plenty now. Think what it is.
You don't talk about it. You don't get through.
He said a dagger.
Oh yeah, be listening.
Payments now too.
Drop one and then they drop her then.
I don't laugh, man. Don't forget
Wait now, for that one, it's
now walk it Go on and enter, make him call. So, oh yeah. Okay. Number 9, cutter. Done. Next, done. Huh? So that one is drilling. Next.
measuring tape.
Next.
PPE tools.
Huh?
PPE tools.
Huh?
PPE tools.
Clap for this guy. This guy undercover every plenty self. He's one in a million question. Answer me. So these are the few. What about hand glove?
Insulation tape.
Which insulation?
Go grab yourself. Come.
These are the tools needed. There is difference between tools needed to work and the materials you need. So don't confuse this. Insulation tape is part of the material needed. It's not a tool. It's just a material you needed to work. So it's not a tool. You give him.
I want to tell him the price and I get it for.
No. So now, so these are the tools. So you think you must use your tools. These your tools must be ready. Ladder ready. Skyfoot ready. Depending on the case. So plier ready. Drilling machine ready. Multimeter ready. Multimeter can test voltage, it can test current, it can test frequency and the rest of others. So get ready your multimeter, get ready your screwdriver. You have all those things here so that they can see it practically. Now let's have all these tools. Let's have all these tools. So now bring multimeter now. You have multimeter now. Let's have all these tools supervisor. Then iron stroke, spooling machine, measuring tape, personal protective equipment, spanner. Now when we talk about spanner, we have different categories of, we have different spanners. Who can tell me the most important spanner in solar work? Which number is more important in solar work? When we talk about spanner, which number? Number 1, 13. 14. 14. 10. These are very important. In fact, if you are going to site, this spanner, most batteries are either 13, 14, sometimes 15. We also have 17. So make sure that you have your spanner handy while you plan for your work. Get your hammer. Get your hammer so that in case there is anything that you have to drive into the wall. So then also get your pliers and the rest of others. Get them ready. Now, I think those are the tools that you need. Those are the tools that you need for you to carry out this installation. Then, another thing that you look out for is look out for the design. Look out for the design. Look out for the design. I want to install 1 cable. How many panels and whatever. Take a look at the design. Study the design. Study the design. Now by the time you study it, you'll be able to know and you'll be able every work has the circuit diagram. Every work have a circuit diagram. Now, today we are going to do a practical. We are going to look at just 1 kVA installation with 100 ounce battery and solar panel, 150 watts solar panel. Okay, let's 150 watts solar panel or 200 watts solar panel. 2. So we want to practicalize how the installation will look like. So now, first of all, I said what we are installing is what? 100 amps solar panel, 100 amps, 150 watts solar panel, 2, 100 amps battery, 1, 30 amps charge controller. Can I have all these things? 1. Now, if I want to install this, these are, why not bring those use ones then? That are 200. Now, these are core things that the marketing team or the sales team will not say, we want to install 100 watts solar panel, 150 watt solar panel, 2, 100 amps battery, 1, 30 amps charge controller, 1. These are the primary things that they will mention for you. I want to install my solar panel. What are the things that I need? I need my feed, guys. What are the things that you need to install your solar panel? 1. Huh? Number 1, you need what? 2. Huh? Bolt and nut. 3. Huh? Aluminium profile. 4. So now, okay, you plasma in case plasma or silicon. Now, the reason why I need this one is that is okay. The reason why I need this one in case anything happens to the roof. Now, look at this. You need a nail to get this, to hook these guys. It's either you are using a nail or you are using a screw. I don't know if you understand. Now, can I have aluminum profile, please? It's either you are using a nail or you are using what? A screw. Now, if I'm using a nail, I'm going to hook this thing on the nail. I don't know if you are getting it. I am going to hook this thing. I use the nail to hold this one to the roof. That one is if you are installing on top the roof. We are mindful of one thing. Be very, very careful to avoid leakage. How many is that? 2. Be very what? To avoid what? Leaking. Very important. When you put your nail, please put your gum so that as your nail is driving in, it's going with the gum. It will not leak. Do you understand? When you are putting your nail in, please put your silicone gum so that as your nail is driving in, it will drive along with the gum. In that case, you will not experience leakage. Because immediately as it's opening it, the gum is pushing in. Power. Can I have a nail? If I have a nail, then I have the aluminum profile. I have to use the nail to open the profile, right? And the nail in turn, and to avoid it, you silicone gum. So drive in. You drive along with the gum. The gum will seal the portion that gets open. Water will not penetrate from there to inside. Did you get that? Now, this is what now I have a video. This I will nail it to the roof. Now, look at another thing. In every roof, there is up and down side. I don't know if you understand. Now, please avoid this using here because this is water line. There are places that those areas are water line. So immediately you open here. If you don't use
I think it's
I think
because
there's gem in my office.
because of breeze, in case you are having a mighty breeze that you won't fall in panel, so that this thing that this profile will hold the panel very well.
Okay, we are installing proper. Okay, clap for us. Now, good. Why the choice of this aluminium, not iron?
Because of electricity.
This guy doesn't conduct, I'm sure. Does he conduct? No. And it's strong. So if I use iron, all this lightning and whatever, iron is heavy. And iron is heavy. Apart from being heavy, so it can attract iron and attract thunder. You know now. If you see iron, I don't know. Some of us that play with our life, there's lightning. You are holding iron. One day. One day. So please, if you see me when there's lightning, I will stay home. Some of us that used to laugh when there's lightning. Sorry. You can follow that. For instance, you are using shower self. You can follow that iron in the shower and come down to it. So, but it's not our portion, sha. So now, this we hold. I will not have to do this. Now, look at it. Sometimes we want to use it will not come out here, right? Yes, sir. Now, between this point, this is where I put, and there. Now, between this point to this point, this thing that is inside there is wasting. You understand what I mean now? Now, if I don't want to waste this material, I will cut this. I will use this at this end. Use at the other end. Now, if I want to do this, I must be able to measure. I must be able to measure. Now, for me to succeed in this, I must measure the distance between here and here. I need one of these also. Hello? Distance between here and here. I must be able to know the distance between the two ends. If not, there will be a problem. You might put the panel. Is either you did not see this again or it's far from each other. So that is why you need a measuring tape. That is why you need a measuring tape. First of all, before you go up, what is the dimension of the panel? What is the dimension of the panel? So that you will know how to position this. What is the where is measuring tape? What is the dimension of this panel? Now, you pick your tape. You measure from here to here. What is the dimension now? I'm seeing 81. I'm seeing 81 mm. Now, since I'm seeing 81, the distance between here, somebody come up. The distance between here, I'll put this one here. I'll now measure from here to here. Is how many? 10. So this is where I'm going to put. And guess what? It's not like this. So I'm just telling you now. It depends on the angle you are viewing from. I was viewing from the other side. So you centralize this. You centralize this. Use the middle. Don't go and use the end. The distance between the middle. So it is that middle that you put your nail. Is that clear now? Now I have. If I succeed in putting it, I will now have something like this. I better go. Not smart. Now, if I succeed in putting it, this is what I'll see. Then the next thing that I need what? Both and nut. Those supply you like this. Now, if you watch this side of the boat, you already have a washer. But if you cannot find this type of boat, that means you introduce a washer under. But this one, we are using this type because we know that this one can roll. Look at it. But if you have bolt and nut that does not have this type of mount, now the next thing that you introduce a small washer, not big one, because big one it will not enter your own. You introduce a small washer here. I was the one that designed this one. Design your own. Now I now put it here. Now this one is what will hold my two panels together. Look at it. I have this panel, I have this panel. I put two of them together, bring that one close. Did you understand? Huh? I tight. Once I tight, then it depends on. I might use this guy too. I might do a, but if you are sure that one will hold it, you can take it to somewhere middle. You can dress this one to middle. That means your panel will go to middle. Or sometimes we use nail. Sometimes we use nail to hold the upper sides. You use nail to hold this one, and you now take this one down so that even if the thing want to go back, the nail will hold it. But anywhere you put your nail, introduce your gum on it, please, to avoid leakage. Did you now understand how we install this panel? So those guys going up that you are feeling that they are jagaban. They are not jaga anything. This is what they are doing, that you feel that these guys are excellent. Simple. But if you think that it's easy, finish. If you think that it's easy, I want to see a female person without serious. If I have a female in the Dee-Jovicx that is climbing, I will put the person on salary. I will be paying the person extra. The person PA. I will put the person on grade A. So any female here that you feel that you have that skill, you can come on board. I want to encourage. If you imagine that, hello, are we together? Listen now, hear this now. Imagine that somebody like Priscilla can climb to install solar. Now listen, look at what will happen. They will patronize Priscilla much more than every other man. Have you ever seen a female driver? They enter their car much more than a male. So this industry, I'm not really seeing female enter this industry that can install solar. I want to train a female. So now, that is how to install. Now, do you know what? Your design will determine your connection of this panel. These are our design, your design now will determine your connection. We are looking at what? 150 watts panel, and what they gave us is PWM charge controller. And I told us in this class, that is our last class or so, my PWM charge controller, it cannot work between high voltage to low voltage. It can only work between close range. Now fine, the panel that I'm carrying, I will use a multimeter. I will turn the panel. I bring my multimeter. Please, anytime you want to install panel, it is important that you take the voltage of the panel first. Don't just take panel and install. You don't know if the panel is working. So now, I put my multimeter. I set my multimeter on what? This. Not this. Then I use my multimeter to read the two ends of this thing. Then I will now be able to know this panel is 18 volts. After I read this panel, I discover this panel is what? 18 volts. I read this other one is what? 18 volts. And my charge controller is PWM. And I want to charge battery. The battery is how many volts? 12 volts, meaning I'm good to go. What is my connection? 15 naira. What is my connection in this case? 15 naira. You'll be fast in booking it. Next person now. Parallel, clap for this guy. So now, I see why you have to pay 15 naira. Collect 15 naira. So now, the connection here is what? Parallel connection. Why parallel? Let me collect money from another person. Okay, let it not look like I am biased. Why parallel? It's like this we move now. We move from here, we go to here, then we are going here. Why should I use parallel for this?
Because the voltage.
Clap for us without even, because the voltage is low. Because the voltage is low. So now, and I use parallel connection. So now, that means, look at what they do in the up there again. So that you know that it's easy. This is what? Positive. This is what? Negative. They will collect this positive. They will go and meet it with on it. Now, Pablo will carry this positive. He will join this and this. Hold it. They will collect this one and join to this. Hello? This is which connection is this? Good. After he has done this, can you use the other hand to this? Now the next thing is you have cable here, small DC cable. Now the next thing is we now put cable here. We put cable here. Guys, we join cable here. Send it. Join cable here. Send it. It will now follow. Sometimes we use connector. MC4 connector. I don't know if you know MC4 connector. You do it in such a way that, see, this one will come, socket. It will now socket to that one socket to the other one. But if you cannot find it, you join properly, please. Join what? Properly. Don't just join like a madman in the street. Join professionally. So when you join this to the cable, as in this case, how many mm? 0. In this case, how many mm are we using? 4 mm. So now I told you before that the current passing through a cable determine the type of cable you use and the distance also. Because the distance that we want to go is not too much, maybe like 15 or 20 meters, we'll now use 4 mm. I hope you did not cut cable. So now this is a DC cable. Now look at what they will do. After they join this, they'll take this one. This in this contest, blue, use blue as positive and black as in telecommunication concept, because telecom like BTS and the rest of others in telecommunication, they use negative signal. They use blue as negative, while black positive. But in this solar contest, anywhere you see blue is what? Black is what? Anywhere you see red, hold on. Anywhere you see red is what? Positive. Clap for her. Anywhere you see black is what? Negative. Yes. I want to encourage our female for introduction, for installation. So now look at it. I connect this to this. I am now taking this into the house to meet this end. Will now go and meet the charge controller. Now please, where will this one follow? It will follow anywhere it follow. Please be mindful so that that water will not leak from there to inside. Did you understand? This cable now, you want to take it to inside. Where are you going to follow? Definitely, maybe you might want to open one section of the roof. Somebody will use hand, Pablo will use hand, drag the thing, tear it open, and when rain starts, rain will carefully follow this guy, go into the charge controller. It will not drop on the charge controller. The next thing, the charge controller will come. I don't know if you understand. So seal properly. If possible, take something to put there and seal it properly so that water will not penetrate. Now look at what happened. We are done with the installation of the solar panel. Can I take off this panel now? So now this wire is going somewhere. This wire now is going somewhere. Assuming this wire is coming from the solar panel. Now, immediately I am done, the next thing is I have to measure the voltage here. Which voltage am I expecting here now? Let's collect money now. Stand up and say, collect 5 naira. 50 naira. Who else again? 18 volts. Clap for this guy. If you are not sure, don't answer. That is the formula. So now, unless we are doing a general answer. Now, look at this. Because it's parallel connection, the voltage coming from this end is what? 18 volts. And is this 18 volts that I'm sending to my charge controller? This is the charge controller. Now, before this charge controller, before this charge breakers, before this charge controller 2 pole, before this charge controller, I don't need to just carry the voltage from panel. If you look at this charge controller very well, you have where they draw solar panel. They put plus and minus. Hello? They draw battery. They do plus and minus. Then why the other one is load. Now, I'll do this. From the solar, from the panel, from panel to breaker, from breaker to charge controller. Where is the breaker, man? How do I now know the breaker to use? How do I know the breaker to use? 15 now. Okay? I like this guy. Soft guy. Unided guy. Unided. I will not. All these questions are for Unided students. How do I know the breaker to use? Okay, you want to save them. This guy said I want to save.
I'm interested.
Huh?
I'm interested.
And now, if you feel it, maybe you will pay money. Save them so that I will not collect more.
Depends on the current.
I could slap for you. This panel that is coming with 18 volts. 18 volts. The panel is 200 watts, Abi? 200 watts. What is the current? At this point now, what is the current? Is it now 200 watts at this point? You have Abi? In a series connection, hello? At this point and this point, this is how many? This 18 volts. This 18 volts. What is the amps? 22 amps. Here will be how many amps?
11.1.
Not
1 or 42.
Okay, this 11 Adi.
Yes. The 1.
Let's say 11 amps.
Yeah.
This is now 22 amps. Which breaker do I need?
42.
Huh? I have 32 amps. The nearest breaker to this one is how many amps? 32 amps. So you use 32. If you can have 25 amps, you fine. So I now use how many amps? 32 amps breaker. Now, single pole or double pole. If I'm using single pole, one wire, one of these wire, the negative will go straight to the charge controller. I will now break the positive. But if I'm using double pole, please, This breaker has plus and minus, and you have input and output. Hello. This breaker has what? If you turn it like this, which side is the input? Down. Your panel will enter down and go up. Don't do like those electricians, no. Precious them. If you want this breaker to work like a breaker, follow the line, input and output. Also, you can look at it very well to be sure. They will write it for you. It's written in, out. Don't put in where you have out and out where you have in. Follow the process so that the breaker can break if there is any issue. Good. Now, I will now install this. I will install this. Also, follow polarity. This breaker has plus and minus. In most cases, plus is always at the right hand. Hello. In most cases, plus, I'm not saying all cases. In most cases, this side is the plus and this is the minus. What you do to A, do it to B. Don't put plus here. You come to this place and put minus. If you close the circuit, what you then the next thing we will hear is this thing is not working. They will call you. Pablo will say the breaker is not working. He will not tell you that I made a mistake that got this thing born. When I tell Pablo, they talk truth. So now, from here, which is the output, I put my wire, the same that I use here, the same will be here. Some of us, we put 6 here. You come here, you put 2.5 You want to go to the charge controller. Wrong installation. You deserve a slap. So now, I put it here. Then the next thing, I take it to the charge controller. Don't close yet. Don't close yet because you are not done. You understand? Don't close yet because what? You are not done. From the charge controller, I will also use here and now go down to the battery. This is the battery. The battery has plus and minus. From my charge controller here, I take my plus to the plus of battery. I take my minus to the minus of battery. I can also decide to introduce a breaker. This time around, the battery is the input to the breaker. That means I have 2 breakers now. One is battery to, and the other one is panel to. Is that clear now? So in some cases, I might not introduce breaker, but in some cases, I might decide to introduce breaker depending on your design. Now, this is how you install panel to charge controller, panel to and to battery. Now, once you are done with your installation, the reason why most time we don't put breaker between the battery and this one is because sometimes some of these people might be so stupid, they will off the battery breaker. And when they off the battery breaker, it will be affecting the panel breaker will be on. In those days, if you are using PWM, it might damage the PWM because panel will be supplying to the PWM and it's not seeing breaker. It will damage this thing. So this is how you install this one. Now, inverter. When you have done this, after you are through with this,
Okay.
inverter is here now. After you are through with this, don't forget that there is already a cable resting on the battery, right? There's a cable that you have connected to the battery. Now, the next thing, you now connect your inverter. The inverter in this case should be how many volts? You are working with how many volts inverter? Hello? Okay, don't worry, not general people. Okay, we are following. Let's look at people that has not answered. This is what I'm true with this. Okay. In this case, the inverter is how many volts? Huh? 24 volts. Clap for him. Well, fine. The question is hereby shifted to the next person. You are promoting our. He's crediting us now. Next, you can find now. It's going to go like this now. Oh, you have 15 naira. Next. Oh my God, clap for her. You see what the woman can do? You see that women, they pay more attention than men. This one, you are busy thinking on how to give out the money. And she's thinking on how to get it to you. You are thinking another thing. And she's focused. Thinking where we are. You are thinking on how to give out the money when the money arrives. You see now? So now, 12 volts. The inverter here is 12 volts. Because the battery is what? 12 volts. First of all, look at every equipment that they give you. Look at every equipment. Don't just carry inverter you put. Even if they release it from, assume that the person that is giving you is massive. Assume that they are not normal. As in, everything that comes to you, you must check. Look at the back of the inverter. Is it 12 volts before you connect? If you have ever connect 12 volts inverter to a 48 volts inverter, what you notice, go and ask Frank, you will know. Or Emeka, ask them, you will know. So now, we connect the inverter. As soon as you connect, it seems the inverter is ready. But look at this. Every connection that we have talked today must be buried inside a trunking pipe. That is why sometimes you see us, we have a trunking pipe. You put everything in the trunking pipe. Now, after I've made this connection to the inverter, I now start thinking, how will this inverter now get supply? So that inverter now, there's something that I need. From the inverter, this is the inverter. I told you people that I have 3 important units. DC input, AC input, Who answer? You answer me? You say what?
Answer AC out.
AC out. At this end, I supply, right? At this end, I supply. At this end, I give out. Is here. These 2 cables is the DC input for this inverter to collect battery. Raise it. These 2 cables is for this inverter, is the DC input for this inverter to collect battery. This cable is the AC input for this inverter to collect charging. Now here is for AC output for this inverter to give out. Come on. This one is for stand up, 50 pieces. This one is for
Mama Jesus.
Oh yeah, be fast now. I will ask you 3 in 1 question. This one is for what? Mona don't say she's not there with us, so are you with us? Where is your mind? Wait, hold on. You have to investigate. Where is your mind? Your mind is there. So what did I say now? What is this cable for? Is it AC or DC?
Oh, chill.
You are going to get here. Concentrate on that. Priscilla, take it. Anybody else? Take it. Come on. This cable is not.
Okay. It's AC. What?
Clap for her first. In fact, it's okay. I'll ask another person. Ruth, this cable, is it input or output? Input. Clap for her. Michael. This cable is what? This cable is what? Platform. You know they have to know some people. Now, which cable we go in here? Michael. Come closer now. I want this money to reflect. I know how to get them. This 15 naira evangelist car method is the best now. Which cable is the cable that is entering here? Is it AC or DC? Michael, another one. Assuming this breaker is meant to control voltage output of this inverter, underline. Which breaker is this? Is this AC or DC? Michael. I should come again. Yes. Assuming this breaker is meant to control voltage output of this inverter. Voltage output underline. This breaker now, is it AC or DC? Answer. So now, on this note, you don't have anything to argue that this guy don't know what inverter is. So. As in, that is what it means now. Now we are going to Frank. Frank, assuming this breaker is meant to control the input, the battery input of this inverter. This breaker, is it AC or DC? The battery input is DC. Clap for him. For video this kind one. So now, this is an inverter. Inverter has 3 basic sections. The input, DC input, AC output, AC input. I have been saying this, I have been singing on this. Now, the DC if you, this guy is not here, come and give this guy chair. Where's Great Khalid? You cannot see this guy sit. Next time you come early and you sit at the front. Stop sitting at the back. I will put my lens on you now. You are not learning this. You are being distracted by forest trading. I mean, what does that mean? You are being distracted. No. Hold on. You know one thing, You know one thing. Whenever you want to learn, always put attention and focus on what you know what you pay now. At the end of this year, we do assessment. I'm going to give you per exam to write, especially you pay. So you cannot just, they cannot pay for you to come for training, and at the end of the day, you are not learning. This is the primary side of it, not joking. You understand? I did not bring this. They did not bomb me with this. I learned it. So the same way, you too, you can learn it. You can train people. At the end of this class, I'll tell you what I want you to do. This class, I'll hand it over to one of you. Like, Wednesday, handle this Wednesday class for 1 month. Yes, I'll hand it to somebody so that I will not equip the person. Like, you know it. You know, when you teach people, you are bound to learn. So I will sit down here and be writing. You teach us. And so I think that is all about that one. You can go. Now, because of this, that output that is coming out from the inverter, I will send it somewhere. That output that is coming out from the inverter, what is time? That output coming out, it will shut down by 10. The output, the output coming out from inverter, I will not send it to somewhere. You can't just take the output and you just put it anyhow, no? So there is a place that will take the output coming out from that output. I might decide to put it on the AC breaker. The output can come into AC breaker before going to the changeover. In that way, I know I break the output. Now, I have a changeover. Most time it's knife. This changeover is made up of 3 basic sides. The changeover is made up of 3 basic sides. The changeover is made up of 3 basic sides. AC. Okay, sorry. Inverter. In. Direct. Then when we talk about direct, NEPA or gen. In. Then. This is a changeover. Now, once you bring in that your inverter, put your inverter here. We in Dee-Jovicx, in our design, down is always the inverter. So please follow our design. Don't introduce your design. Otherwise, me and you will get issue. Hello? Now, do you have small trunk and pen? Look at this. The wire that is the cable that is coming from the inverter output, AC output, will now come in here. Hello? When it come in here, that means anytime I take this changeover down, bam, I'll have voltage from where? Good. Now, Did you ever think of a very good day that the inverter is having issue? The inverter did not work. The inverter is having problem. It's not working. Now that is why we now think of this place. You supply your either from your NEPA direct or from your gen direct. You now supply it to this place so that any day that you are having issues with the inverter, if you take it up, anything that comes in either NEPA or gen will go in here. Hello. That is how you connect this one. Now look at the trunking pipe. I went to a site. The Aboki man. Look at what the Aboki did. He connect the cable.
That electrician will also.
I don't. You understand now? In Dee-Jovicx, this is what you do. In fact, we don't want to see cable flying. We hate flying cable. You put another trunking pipe here. And put another trunking pipe here. Everything must be what? Buried. Everything must go inside this pipe. Please, no exposed cable. No exposed cable. Michael, what did I say? I'm sure that even when we are lecturing, you are still doing forestry. Are you foresting? So now, this is 1 kVA inverter, and I bring out the output. If I just send the output into the house, that means the fridge, the AC, everything will be under this inverter, and they cannot be off washing machine, off fridge, off AC. No. Now that will take us to what we call load separation. Load separation. That is our next topic now. What is load separation? No, let's start from back. What is load separation? This thing, what is this thing?
You don't want the
Sit down, you have an idea. In my house, I have AC, water heater, water pump. That is similar now. What again?
Cooker.
Electric cooker. Fridge. Oven. Chioma say washing machine, right? This your mother said it. Washing machine. First time when you talk something don't make sense. Washing machine. So now, I have washing machine here. Do you know that all these things that are in your house, there is a place that they come to? And that place that they come to, I will answer this one. I don't know if I want to say it. That place that they come to is called what? Distribution. Is it bus or board? It's board or distribution panel. Now, we have different types of DB. I taught it here. We have 3-phase, we have single phase, right? We also have the one that have 12 star block, 16 star block, 8 star block. When I say star block, I mean fuse and breakers. Now, we want to take a case, a common case, because 3-phase DB is common in the house. Now look at how DB look like. It have neutral, live, live. Now, assuming the neutral is like this, then we now have live. We have another one. We have another one. There are a set of breakers here. Oh. Now, if I want to connect this washing machine this AC water heater, pumping machine, cooker, fridge, in no particular order. You understand? Maybe when you get to, you see that this is your, when you open that thing, this is the connection they do. They connect the fuses, the breakers are connected to different things. Then they now have a common neutral that all of them that come in, they goes to the neutral. They goes to the neutral. This place, all of them comes here. But the breakers separately. Now, I get to this type of house. And I install solar. This is the connection. How do I now separate? That is no separation. I have to bring out that section for inverter, bring out another section for direct, that is the main load. Now, what about I free this line? And look at this, so normal connection at home have these two joints. You understand now? All these are joined together. Now, because I want to install solar, if I come here, I will remove this one, remove this one. I want to use the middle one, and I'll take this one out. See where I'm taking it to. Then I loop this and this. You understand? This one now, nothing is here. Everything that is for the inverter will come in here. Everything for the inverter, from the inverter, like I remove the bulb, I carry life of this cable, I remove it from where they are here. I put it, this line is dedicated for inverter. Please don't join it to this one, please. Now, after that, I take the neutral, all the neutral. I bring neutral from inverter. I bring neutral from inverter. I bring all the neutrals of all these things together and I join it to the neutral of the inverter. In that note, I've separated the inverter from the main load. Then from this main load, this is where I will take for charging of my inverter. I will take it to the other side, the upper side of this thing. Is that clear now? Huh? So if you want to know more about load separation, follow them to site. They will teach you. So this is just the primary. Then we have separated loads. We we have the inverter, we have this one, then we power on. You will see everything is to work. Did you get now? So this is a practical installation of solar panel. Be mindful of the voltage. Be mindful of the voltage. Follow the design. When you are working, ask. What did I say last? Maka? Oh yeah, fine. Maka, what did I say last? Stand up now. What did I say last? So you were actually here and you were closing your eye. The year was that. So do we want to take questions from installations site? After that, I'll ask you my own, then we'll call it a day. We have tried for the day. So please, I want to take questions. Oh yeah, go ahead.
In a case whereby a customer provides an inverter and the inverter, there was no data sheet on it, and the customer is saying that this inverter is 1 kV, but there is no data sheet to show you that this inverter is only 1 kV. What should you do?
You lose the inverter. If you lose it, 1 kV has number of MOSFETs that you carry. It has the size of transformer. You even see where they write it inside. So you can use it and be sure before install. Don't just put. But if the customer insists, then tell the customer. See, show the customer battery and this. But touch it. If you are sure, touch it before I start, so that it will not be like you are the one that got it damaged. Answer your question.
For this load separation, since you have separated those this thing from the inverter, like in the line of that inverter side, does that mean that if like NEPA things light, the thing will not power those things?
No. Look at it. I have line 1, line 2, line 3, and neutral. Now I decide to use before this is NEPA come. NEPA. Now this is inverter. Everything on this line, lights, sockets, blah blah blah, is on this thing. So if there is a supply from NEPA, it will not flow into here because there is no connection to this place. It's only inverter that is connected to that place, unless they did not do it well. Unless they look, and if they bring that, the next thing you hear is what? So did I answer your question? Next question time.
My question is about this. Let's say now inverter is having issue now. The inverter is bad, and you change your night switch. Meaning all the loads on that inverter line will be like
If you change your night switch up,
yes.
see, look at the night switch. This is the changeover. This one come from inverter. This one come from NEPA or gel, right? Yes. Now, if I change over to up, it will take the system to this one. This one you are picking it direct from, you know that changeover that you have, the main changeover, NEPA and gel out. Then this is the out. You take from here. This is your main changeover for the house. That is where you collect from here, so that anytime this guy is not working, once you change over there, it will now take all the load here to the other side. So on that side, that one now will not have light. You have cut off the inverter. Next question.
I want to confirm because this switching, if there is light, I want to know if it's the inverter that will switch from NEPA from solar to NEPA. By itself.
The inverter has UPS function. What is UPS? Huh? As long as your changeover is on inverter and those loads are not more than the capacity of the inverter, when the inverter senses electricity, when it senses, say the input side of the inverter now sense there is a power supply, it will automatically switch to the load. That is why if it is 185 volts coming from BEDC, that is NEPA, now it enter inside the inverter, immediately it enter, the output of the inverter will be what?
185.
I don't know if you understand. The inverter will automatically bypass. It will bypass. It has a bypass function. That voltage that is coming straight from NEPA, it will not take it down as an output. So that is why if your BEDC is 185, you see that the inverter will now bring 185.
Is it all inverter that have that?
Almost all of them. Almost all of them. Unless the inverter is old inverter. They have that function. So it has automatic switching. You will not even know. The only thing that you know is that either your light become higher or lower. If the NEPA in that area is higher, is above 220 and the inverter is 220, it will take 240 that. It always take the voltage coming from the grid. Next question.
So about that load separation, if you are connecting to the
This
inverter,
guy's like low separation, no.
if you are connecting to the inverter, you mentioned the 3 lines that you use one particularly for the inverter and you look to the remaining 2. Does that mean each and every load that is connected to the direct line cannot be connected to the inverter?
Let's go now. The inverter we are working with is 1 kVA, right?
Yes, sir.
And can 1 kV carry AC? AC is how many? 1 horsepower AC is how many watts? 1 kVA inverter is so only the AC now is more than the inverter. So if I connect this AC on this inverter, it's going to crash the inverter now. So for that, you must separate your load. Did that answer your question? Next.
Sorry, still concerning this load separation. Yes, so if you now separate the load, you now say, okay, the inverter will be carrying the lights and that thing. So that means that when NEPA comes, it's either there's NEPA and there's inverter on, so that the lights can be on, because the NEPA is not connected to the light. You understand? Because the two of them. Lights.
Let him conclude. You might have something.
Okay, let me come again. Now, in this house, there's AC, and my AC, my inverter cannot carry the AC. So they are in one line. You understand? Then the lights in this house, my inverter can carry them. So I connected them to my inverter. So that means that if there's NEPA, my lights cannot be on, because it's only my inverter that can power the lights. Or is it that I will on the NEPA and on the inverter at the same time so that everything can work?
Can I do an illustration?
Because it's still the same question that this guy has.
He asked you or he asked us?
So he asked us the same question.
Which guy?
This guy, almost similar thing. That's what they are asking. I think even this guy, they are still circling around one thing. Yes, and let me
Do an illustration.
You have line 1, line 2, line 3. Hello. Hello 1, hello 2, hello 3. So I said something about changeover. And another changeover. NEPA, gen, inverter, NEPA. The output of here supplies here. Yes. No. Okay, sorry. Don't say sleep. Supplies here. From here, from this place, supplies your line 1 and line 2 NEPA. I don't know if you understand. Then this line 3 now that your load is under, 1 kV is under inverter. Here goes to this place. I don't know if you understand. This your line 1 and line 2 is directly under NEPA already. Okay. Why this changeover controls your line 3? I don't know if you understand. This changeover is either
You can as well introduce another DB
for it.
if you wish. You can introduce single phase DB. Sometimes we do it. I don't want to tamper with the line. But the real this thing you want to do, you want to save you as you want to do it normally. I don't want to tamper with the line. The next thing is you bring out a DB. It could be, let's say, single phase DB. Now you move everything that is under inverter to that DB. We did something like that in Fisherman's place. You understand now? You now migrate everything that is supposed to be under inverter to that DB. Simple. Now the model wiring now carries 2 dB. One is for heavy load, one is for inverter load. So whatever thing you want to put on the inverter comes to that inverter. The one that you want to put on heavy load comes on heavy load. We are having this issue because we are marrying old installation and new installation while trying to cost. So you can see them. Just one, you can ask many.
Describe something about this being for the inverter. Now you have, because when I went for installation, I was hearing when I went for installation, I was hearing something from the electrician saying this switch or socket was for and one was for like NEPA and gen. So that was kind of confusing because if you take all the power to one line, can you connect that same like switch to 2 of them? You connect that same switch to line 2 and 3, then connect it to line 1 again to the inverter. And reload. Let's say a light bulb in the middle.
Hold on. This is 2 dB. 2 dB. And this dB now is for inverter. Then this dB is for heavy load. You are talking about the working and stuff, I know. Have you?
Yes, sir.
Good. Now, if you install your inverter, you will not send your inverter output to this dB. Finish. The work has been done down for you. Now, this dB is where you have your bulb, small load, all those your load that is under inverter. If you have your SIMO, whatever is under inverter will be here. Anything you want to be depending on the rating of that inverter will be here. Now, why this your dB is where you have those things that are not under inverter. And this dB is taken from this changeover. There is an existing changeover in the house before you come. before you come to that house to work, there is a changeover they are using. And they say this is for their NEPA and this is for their gen. Now the output of this changeover, just as Emeka explained to you, goes to this DB. This is their house changeover, right? Now the output of this changeover goes to this DB. Now we now have our own, we introduce our own changeover somewhere. Now this our changeover have inverter. Where we now put our inverter. Then the output of this our changeover goes into this DB. Did you understand? Now look at this. So this is your inverter coming in. Now sometimes this inverter might have issue that this changeover now need to work in two ways. In case the inverter is not functioning, I can change over somewhere and have my normal light. Now this your changeover is going to collect from this place, from the same place that you collected. Sometimes we might collect it from this point because it's the same thing. Did you get it now?
Yes, sir.
So did we all understand this now?
Yes, sir.
So even if I'm not giving DB, I might still decide to do this inside the existing DB. By releasing one line, as long as that house is not three phase, I just free one line and use that one line. But if you are confused, tell them to get DB for you so that you can now pack everything and put inside your DB. Next question. So you are ready for my own, Abi? 15
That's fine.
How many are we? Okay, question number one. We start from the front, and the more we go, can I have this fan electric? We start from this order and go like this, and the more we go, the harder it becomes. Question one. I have stand up now. Which tool is used to measure solar panel voltage? Which tool is used to measure solar panel voltage? I will not repeat the question along option. Once I give you your answer, and if you know it, you just call. Clap for him. Question: before connecting solar panel, what is the first safety step? A. Switch on the inverter. B. Wear protective gear. C. Connect the load first. D. Bypass the fuse. What? Clap for him. Question number 3. The positive DC cable is usually identified by A. Yellow color. B. Red color. C. Blue color. D. Green color. Red color. I was starting to say blue, sir. So when you have blue and red, which one is your positive? Red. Clap for yourself. Why should a DC breaker or fuse be installed between battery and inverter? A. To decorate the system. B. To regulate charging. C. To protect against short circuit. D. To increase voltage.
Even cross leg.
have said before that we will not come again. Wait, our movement is what? What is on? We always move in here in the Dee-Jovicx. Our movement in this training, not the Dee-Jovicx. Our movement is like this. See, we move in. Hold on. Let me tell you why I use this. There's something we call AC and DC. We move in an AC mode. We don't move in DC form. If it's in DC form, we'll be going like this. We move in AC form. Now, for the last time, I'll give you this question. Why should a DC breaker or fuse be installed between battery and inverter? A. To decorate the system. B. To regulate charging. C. To protect against short circuit. D. To increase voltage. C. Clap for her. Question number 5. When using a spanner on battery terminal, the correct order is A. Tighten negative first. B. Tighten positive first. C. At once. D. It doesn't matter. It's not everything that teacher will teach now, Abi. It's not everything now. There are some that you will not teach. If you people have been writing an exam, if they give you questions, some they did not teach, they will say that. It doesn't matter. It matters. So the correct answer is A. Tighten negative first. Let me stop. Don't book him. Don't book him because I didn't teach this one. Or I should give you. Let me give you your next question. Whenever you are walking, hold on. What carry most weight is the positive. You understand? Because positive is the one that has more weight. Always start from negative. If you want to tight on negative first before you go to positive. When you are doing it, it's fun. Right? Then pick your another question now. If a single panel reads 37 volts VOC, two in series should give how many volts? A. 18.5 volts. B. 37 volts. C. 74 volts. You say what? B, Abi? He has given answer now. You fail it. What did he say? He didn't say anything. I'll give you another question. Panels connected in parallel will A. Increase voltage. B. Reduce voltage. C. Increase current. D. Reduce current. 50 bam. The answer is it to increase current. Number 8. The teeth angle of a panel in Nigeria is usually A. 45 degree. I thought it's here. B. 15 to 20 degree. C. 0 degree. D. 90 degree.
Yeah.
It's a lie. The answer is B. 15 to 20 degree. Charging. Question number 9. Which collector is commonly used in a solar panel wiring? I will mention it. A. T connector. B. MC4 connector. C. USB connector. D. HDMI connector. Clap for our MC4 connector.
Hello?
Question number 10.
Give me.
You can't run
You might want to answer this first because later it will be harder. That is why when Priscilla come earlier, she was staying at the back. I was having pity for her. The best direction to face solar panel in Nigeria is A. North. B. B. South. C. East. D. West.
South.
Wow. Question number 11. What should be connected to the charge controller first? A. Solar panel. B. Battery. C. Load. D. Inverter. Battery, clap for him. Which controller type is more efficient? A. PWM. B. MPPC. D. MPPT. E. AC controller. C. MPPC. MPPT. Question number 13. What happens if you connect battery polarity wrongly? A. System work normally. B. Controller may be damaged. C. Voltage double. D. Battery charges faster. B. Clap for him. Question 14. Two 12 volts 200 amps batteries in series equals two 12 volts 200 batteries in series equals A. 12 volts 400 amps. B. 24 volts 200 amps. C. 24 volts 400 amps. D. 48 volts 200 amps. Huh? You said A. Fail. Answer is B. 24 volts 200 amps. Question number 15. The correct unit for battery capacity is A. Watts. B. Volts. C. Amps hour. D. Ohms. The current unit for battery capacity is A. Weight. Watts. B. Volts. C. Amps hour. D. Ohms. Collect money from me. What do we measure battery with?
Amps hour.
Clap for yourself. Question number D is on inverter and load. 16 out section B 16. The main function of an inverter is to A. Convert AC to DC. B. Convert DC to AC. C. Store power. D. Generate sunlight.
Convert DC to AC.
Clap for him. 17. What should be used between inverter and battery for protection? What should be used between now this question for now Emeka question for what should be used to convert what should be used between inverter and battery for protection? A. Fuse or DC breaker. B. Switch only. C. Cable tie. D. Earthing rod.
A.
A. Clap for one now. The output voltage of an inverter in Nigeria is usually A. 12 volts, B. 24 volts, C. 48 volts, D. 220 to 240 volts. Electro. D. Na D dey talk. If inverter is overloaded, it will do what? A. Increase output. Reduce charging. C. Trip or shut down. D. Burn immediately.
C.
C. Clap for it.
Okay.
Question number 20. Which load is not suitable for small inverter? A. Fan. B. LED bulb. C. Electric cooker. D. TV.
Electric cooker.
Clap for him. All these questions are so cheap. Now, my question is coming from section E, testing and troubleshooting. Question number 21. Which device confirms that solar is charging the battery? Okay. Question number 21. Which device confirms that solar is charging the battery? A. Multimeter. B. Charge controller. C. Inverter. D. Lamp. Yeah?
B.
C. How many answers are you giving me? What did you answer first?
Repeat the
No. Point. Question 22. If a panel shows no voltage in sunlight, the most likely cause is A. Overcharging. B. Loose connection. C. Strong sun. D. Clean surface.
loose connection.
How for him? I was thinking you played it self. Hard work. That money you are collecting from forex, using it for. If battery voltage is too low, let's personal. If battery voltage is too low, the inverter will A. Continue running. B. Shut down automatically. C. Charge. D. Damage solar panel. Huh?
Shut down automatically.
Laugh for him. Question number 24. Which of the following reduces system efficiency most? A. Teeth angle. B. Dust on panels. C. Cable locks. D. Breakers.
Dust on panel.
Laugh for him. Question 25. To troubleshoot a load not powering, the first step is to A. Replace the inverter. B. Check battery voltage. C. Disconnect solar. D. Remove breakers. The answer is B. Check battery voltage. If the inverter is not working, the first thing you do is check the voltage first. It's not powering. Check whether the voltage is normal. Now, question F, coming from maintenance and best practice. 26. How often should panel be cleaned in a dusty area? In a dusty area, how often should you clean panel? A. Every 2 to 3 weeks. B. Once a year. C. Every day. D. Never.
2 to 3 weeks.
The dusty area. Question 27. Which battery type require topping up with distilled water? A. Lithium. B. Flooded. C. AGM. D. VRLA. B. Abi?
Yes, yes.
Boy, the answer is flooded. Flooded means tubular.
Yes.
Now, stand up for your question. The best cable size. You were looking for my mouth. The best cable size depends on A. System voltage and current. B. Panel brand. C. Inverter color. D. Load type only. A. Correct. Clap for him. Finish. So. Okay, why should system earthing be done? A. To reduce panel voltage. B. Protect from electric shock. C. Increase battery life. Then D. Save inverter.
Project on the head.
have it. God have it. This is the last question, so don't mess up the question. I don't have another question. Question number 30. A daily system log should include A. Solar voltage, battery voltage, load status. B. Only panel brand. C. Only inverter size. D. None of the above.
I did not get the question. Come here.
No answer.
I did not get the question. Come here.
Should I give you another question? Huh? Next time, I think Admi will be the first. Admi and this guy, they will be the first to be answering the question. So that. Now, when dismantling a solar system, what should be disconnected first? A. Solar panel. B. Battery. C. Inverter. D. Load. It's like me on the baby. Unfortunately enough, this question is for the fit guys. But unfortunately, okay, I don't want you to pay 0.1% per
Oscar.
No.
That
Okay, there's so many points.
Pablo.
Let Michael answer for you. Oh yeah, give us the answer. No. Admin, give us the answer.
So come again with the options.
Which, when dismantling a solar system, what should be disconnected first? A. Solar panel. B. Battery. C. Inverter. D. Load. I want to pay 50 back. Guess now. Is it 15 naira that way you are doing like this?
You can write your name.
Answer this.
No.
God help you.
It's like you want to go into prophetic to get the you go into manufacturing. I'm going to make you go. How many?
People, we don't have time.
Okay. One president answer for you.
Don't waste time now.
Yeah, we can answer for you.
No.
Wait, is it 15 naira that?
We are close.
15 naira that? Everyone will say.
I dash you. Call it a day.
What's I will give flying children?
A. Solar panel. B. Battery. C. Inverter. D. Load. What? When dismantling a solar system, what should be disconnected first? We are shutting down.
Load.
The answer is solar panel. First,
That's baby, yes.
another applause for us.
Yes.
So far so good.